It is the best example of overcoming adversity in space travel. Albeit the two Explorer tests have been going in space, beginning around 1977, they proceed with their progressive exploration mission to this day. As is notable, the indistinguishable twin tests have now even entered into interstellar space, where they are giving us extraordinary bits of insight into obscure, enormous universes. But this is only one side of the galactic coin. The reality is that the shuttles are currently showing serious indications of weakness, and as of recently, it even looked as though we would need to say farewell to Explorer 1 for good. It was in danger of falling silent forever due to a serious technical inconvenience. Luckily, NASA figured out how to breathe new life into the old test by performing an incredibly dangerous maneuver. By the way, it currently seems that we have only gained a little more time. What's more, we should slowly begin getting used to the possibility that even the longest research mission in history will eventually reach a conclusion. Nearly 50 years in space have caused significant damage. NASA's Explorer 1 and 2 tests have indeed stood out now and again with a couple of technical diseases. Just recall the confusing data glitch that Explorer 1 sent back to Earth from spring 2022 onwards. Although the rocket was generally working as expected, the telemetry data it communicated essentially didn't seem to make sense, and it took NASA researchers a while to uncover the reason for this unwanted issue. Clearly, Explorer 1's attitude control system had erroneously tried to route its data through an onboard computer that had long since been shut down. Eventually, however, the specialists were unable to determine the reason for this wrong data redirection, but more importantly, they were able to use the Deep Space Network radio receiving antennas to get Explorer 1 to send its data to the right, still unblemished onboard computer again. Anyway, consistent with the maxim "one confusion seldom comes alone," it only required a couple of months for NASA specialists to deal with another huge issue. This time, however, it was Explorer 2 that caused the earthly specialists a migraine. A wrong command had caused the test's receiving antenna to skew by 2 degrees, and consequently, it pointed past the Earth. And while the data sent to us literally missed us, an interstellar shout was eventually required to address a radio antenna alignment. The following shows that you also need a great deal of patience for such an interstellar shout, since Explorer 2 was 19.9 billion kilometers away from Earth at the time of the correction command. It took 18.5 hours for the signal to reach it. Thus, the science researchers had to wait just as long for the response. But following 37 hours, the relieving response finally arrived at the Earth-based research stations, and contact with Explorer 2 was restored. How NASA engineers performed a technical miracle. However, even in the period that followed, the Explorer program staff had no good reason to complain about a lack of work. On November 14, 2023, Explorer 1 made headlines again when it was no longer able to properly bundle and send the unique data from interstellar space to Earth. The reason was a defect in the computer system responsible for bundling the data records into sendable packets. Specifically, the problem was with the Flight Data System, FDS, which collects incoming data from the instruments and other equipment parts and converts it into a compressed bundle of zeros and ones. The data packet is then sent to the Telemetry Adjustment Unit, TMU, which eventually sends the data to Earth. Most importantly, it was precisely at the junction between the FDS and TMU that the issue emerged, since communication between the two systems was no longer working properly. The TMU just sent a repeated sequence of trivial zeros and ones, very much like a stuck record. And despite the fact that NASA specialists tried to restart the FDS as soon as December 23, the salvage attempt was initially doomed. The issue could not be addressed this way, and those in charge even said that it would take a miracle for them to get Explorer 1 back on its feet. But as we all know, miracles do occur occasionally. In April of this year, the hotly anticipated news broke that the ancient test was, at least, sending data again. In the run-up to this, the specialists had put about reducing the FDS issue more definitively and found that the core of the matter lay in a faulty computer chip. The corresponding chip, thus, contained the program code that actually checks the data processing before transfer. The NASA engineers then played with the possibility of basically replacing the missing system code and storing it elsewhere in the onboard computer. The problem, however, was the fact that the storage space on Explorer 1's obsolete computers is, to put it mildly, a little restricted. But the Explorer team found an effective fix to this. True to the maxim, if it doesn't fit, make it fit, the specialists developed a plan to break down the affected code into several parts and then store these segments in different areas of the FDS. However, the original program code had to be adjusted accordingly. What not references to the original storage area had to be replaced. Moreover, the specialists inserted script lines that showed the onboard computer where to find the next piece of code on its disk. Furthermore, with a change to the packaging script and the transmission of the new program code piece, Explorer 1 finally sent back the required technical data. The following steps were also successful. After a while of hope and fear, the test finally sent scientifically valuable data from its research mission again, despite previous line blockages and nozzle issues. Besides all the past Explorer crises, NASA has now also imposed a starkness program on its old tests that is designed to extend the life expectancy of their main systems and significant instruments. More specifically, the specialists have now deactivated a backup system that absorbs voltage fluctuations and has its own little power reserve. For this reason, the energy supply originally planned for this can now be used for the continued power supply of the scientific instruments. Tragically, this NASA protection measure doesn't give an answer for the fossilized fuel lines of Explorer 1. The test is, in a general sense, reliant upon little positioning engines to accurately adjust its radio antenna to the Earth. These engines, which are fed with liquid hydrazine, write the antenna's arrangement with a couple milliseconds enduring pushes. When Explorer 1 set out into the vast expanse of space on September 5, 1977, it still had 3 of these engine sets, 1 for course corrections and 2 for disposition control. But with age, more and more a throbbing painfulness came, and the stores that had gathered in the fuel lines over the long-term forced NASA to change to the second arrangement of positioning spouts as soon as 2002. Tragically, however, this too was at risk of becoming stopped up sooner or later. So, in 2018, the switch was made to the third arrangement of spouts, which was actually designed for course correction. Furthermore, now, 6 years later, this set is also in rather unfortunate condition. And that's still a mindful evaluation. As a matter of fact, the course correction spouts have been impacted considerably more than the 2 position control sets. Communicated in figures, this means that, as it were, 0.035 millimeters of the previous inner diameter of 0.25 millimeters remains, which isn't even half the breadth of a hair. This hazardous spout change saved Voyager 1 again, since the spouts were in danger of failing as soon as possible. As a result, NASA decided to return to one of the 2 previous spout sets. However, what appears to be simple on paper is easier said than done in practice. Explorer 1 has barely any energy left due to its old age, and any power utilization can hypothetically bring about the failure of a fundamental system. But without power utilization, it simply doesn't work. In order for the deactivated spouts to be set back into action at all, they have to be preheated. However, the energy required for this must be provided, assuming that the specialists switch off another part. The problem here, though, is that every one of the systems that are still running is key, and, in the case of the scientific instruments, there is also the risk that they can't be turned back on later. The thoughts of NASA's specialists were, therefore, a technical tightrope walk, and after weeks of considerations and tests, they concluded that shutting down one of the main heating units represented the least risk. So, it happened that on August 27, 2024, it was shut down for an hour while the spouts preheated during that time. And while those hours might have felt like quite a while to the researchers, not to mention the around 22.5 hours that a sent message takes for each leg, a deep breath of relief was finally heard. The engine trade was a success, and Explorer 1 is now ready to target Earth again. Well, basically until further notice. As mentioned, the reactivated engine set is far from shiny new. It is too currently contaminated with deposits that, when required, could lead to its shutdown. And speaking of shutdowns, in the case of Explorer 2, NASA has recently deactivated one of the 5 still active science instruments on board. As with the previous cost-cutting measure, this step was also due to the lack of energy, And since the plasma sensor seemed the most non-essential to the specialists, its scientific use is now a thing of the past. But does this now also mean that Explorer 2's data collection will have increasing gaps in the future? Well, luckily not. Since the corresponding instrument was initially intended essentially for measuring solar wind particles, it was also pointed towards the Sun. However, since Explorer 2 has now entered interstellar space, the direction of the plasma streams has also changed, and the particles are now moving towards the Sun rather than away from it. In simple terms, the pipes of the plasma sensor are pointing off course, which makes them pretty much useless. On the other hand, another instrument of Explorer 2, the plasma wave subsystem, is still active, meaning that it can continue to detect plasma flows and turbulence. With everything taken into account, the previous salvage measures and power-saving plans should extend the lives of the 2 Explorer probes into the 2030s. And maybe, at that point, we should remind ourselves once again that the NASA specialists of the 1970s had predicted a lifespan of only 5 years for the twin probes. Well, how wrong could they have been? But even if the day comes when the probes finally hit a dead end, they will continue to fly through space and will quietly tell our world for a long period of time to come. And to tell us quietly about your world, you can easily do so by tapping on the like and subscribe buttons. Become part of our community now, and never miss another video from us. We'll see you.